How does a blockchain work? Well, let's look at this diagram in order to understand. A blockchain is a peer-to-peer network of computers called nodes that all talk to one another. So if you remember in the last video, I talked about how the blockchain is a network and a computer. You can think about it in both of those ways, right? So it's a network that people can connect to, and the network is comprised of computers, called nodes that talk to one another. And each of these computers gets a copy of all the data on the blockchain, the public ledger, right? So that's, how the blockchain is also a database, right? So this will be the computer, will be the node, and also the database. And that, responsibility is duplicated by, pretty much every node on the network. And it's a network because they all talk to one another, and it's a network that we can connect to. You could imagine like a user right here that's connecting to this network. So if the blockchain supports programs, and it supports smart contracts, then each node on the network gets a copy of the smart contracts. That's just part of the data on the blockchain. And it's also part of, the code or the programs that's going to get executed. So each, computer or node in the network is going to share responsibilities of executing the code that's run by the smart contracts. And so this is kind of like having a bunch of redundant web servers that all do basically the same thing. And we'll talk about why this redundancy exists in a minute. We'll talk about more about the specifics of nodes in the next section when we talk about Ethereum specifically, the Ethereum implementation of the blockchain. I've just got an Ethereum diagram pulled up here, but this is going to give us kind of a good general overview of how blockchains work, to begin with. All right, so let's talk about kind of the other part of this equation on this side of things. So if you're going to connect to this blockchain, as a user, you need an account. We talked about that in the last section. This will have an address that's going to be, your unique identifier for the network. It's going to be sort of like your username. And you'll have a public key and a private key, which we'll talk about more later, but just, know that for now. And, you'll have this address, this unique identifier that, tells you that it tells the blockchain that you are you. And, in order to use that, you'll need to connect to one of these nodes that will, sort of be your liaison for talking to the entire blockchain. It'll be, your single point of contact that will represent, your connection to the blockchain, because it's going to be doing what, every other node on the blockchain is doing. So they all have redundant responsibilities. So you could, theoretically connect to any of them if you had access. And so you could, run this node yourself, or you could connect to it with a URL. And we can see a breakdown of what's, going on inside of a node. Here's basically, for Ethereum, here's the EVM client, or basically, the computer, quote unquote, part that actually executes programs. And here's, a local blockchain database that's going to exist on the node. And these would be two things that work side by side to, run the node itself and be the computer. So if you're new to this, this might raise some questions. Like, how is it safe to do this? How is it safe to store data redundantly on a bunch of other people's computers, like, that you don't know? What about discrepancies, right? There's some problems here. Is it safe to share data securely across these devices? What about discrepancies? Wouldn't that throw off account balances? If you're storing money on the blockchain, what would it mean if, my computer said that I had 10 Bitcoin and your computer said that I had 5 Bitcoin? That would present a problem, right? Like, why can you do this? How would you ensure that everyone has a same copy of the ledger? Well, this is a problem called basically a consensus problem. Consensus is just saying that we come to an agreement that our data is the same. If I'm storing Bitcoin on a blockchain, then, my node needs to say that I have 10 Bitcoin, and your node also needs to say that I have 10 Bitcoin in order to reach consensus. So we can understand our consensus problem with an illustration. And this illustration gets used a lot when understanding blockchain, and it's called the Byzantine generals problem. So the illustration goes something like this. There are, 3 generals, or, multiple generals, however many, that are surrounding a city, and they want to attack it, right? That's their goal. That's their incentive. They want to attack the city, And, when it falls, the goal is met. But each of the generals has a conflict, right? They can attack the city or they can just retreat, right? They can just leave and live to see another day. And if everyone attacks, they get what they want. But if only a few attack, then the ones who do are just going to get slaughtered, right? And all these generals have to be coordinated on what they're going to do. And this is sort of the part of the illustration that highlights the consensus problem on the blockchain, is this idea of communication. Each of these generals can only communicate by a horse messenger, and each of these horse messengers can lie or get killed along the way. So the general might receive false information or may not receive any information at all, right? And furthermore, even generals could lie and tell the horse messenger the wrong thing to the other general. So if any one of these generals miscommunicates, like if General 1 tells General 3 to retreat and General 3 tells General 1 to attack, then, there's an issue, right? And someone's going to flee and someone's going to attack and the whole system's going to fall. And this is the problem the blockchain tries to solve when getting all the nodes to talk to one another. So how does it do that? Well, the solution is called the blockchain's consensus mechanism. The consensus mechanism is the part of the blockchain that allows all of the nodes to talk to one another and actually reach consensus. It's going to say that my copy of the blockchain is the same as your copy. My data is the same as your data. If I have 10 Bitcoin, my machine says I have 10 Bitcoin and your machine says I have 10 Bitcoin, right? So this consensus mechanism is used anytime that new transactions come into the blockchain, right? If I want to send some Bitcoin, that's going to go to a node, it's going to get broadcast the entire network. And if consensus is not reached, then the transaction is going to get rejected and it's not going to be recorded on the blockchain, right? And, I won't send any Bitcoin, I won't send any cryptocurrency. But if consensus is reached, then it's going to get recorded and it'll actually transfer the balance, from one account to another, and it'll actually be there forever in the history of the blockchain. So different blockchains have, different implementations of consensus mechanisms. These are the kinds of things that people are experimenting with all the time, coming up with new consensus mechanisms for blockchains. So some examples are proof of work, which is, what Bitcoin runs off of and what Ethereum currently uses as well. And we're going to talk about each of these consensus mechanisms later more in depth in the bootcamp, right? In the next video, we're going to talk really specifically about Ethereum's current consensus mechanism, proof of work, and also I'm going to touch on, how it's, potentially going to move to a proof of stake consensus mechanism in the future for Ethereum 2.0. All right, so that concludes our high-level discussion, of how a blockchain works. In the previous videos, why would you use a blockchain in the first place? What is a blockchain? These have all been high-level discussions about general blockchains, and just sort of getting your head wrapped around the concept initially. Now we're going to actually dive in deep onto how Ethereum works. So check out that next video.